Hi to all, welcome back to my channel. This is KVS, a mentor for JEE Mains, CBSE, Advanced, and also for all other competitive exams. My dear students, I wish you all the best for the coming JEE Session 1. Many students requested me to do binomial theorem in best way, in simple, easy, and elegant way. In this video, I would like to bring some basics in binomial theorem. So binomial theorem will give lots of insight about the numbers and Pascal triangle, how the numbers are arranged in a triangle form, and also many interesting things in binomial theorem we are going to explore. Without late, here is that. So here binomial expansion here. So we know that whenever a plus b, whenever two terms are given, so that we call as a binomial. So we call it as binomial. So suppose a plus b whole power 0 is given, that means equals to 1. Only one term is there here. Power 0 means one term is here. And if the power is 1, a plus b to the power 1, so it will directly a plus b. Only two terms are there here. So two terms, I mean power plus 1, two terms here. And a plus b whole squared, that is the best universal formula. A squared plus 2ab plus b squared. So here three terms are there. Here three terms, and the respective coefficients are 1, so 2, 1, 1 to 1 here. So here the coefficients are 1, 1 here. So initially is 1 and last one also 1 here. So by using these two, I can write the next coefficient. So starting one remain the same, first one remain the same. Sum of these two will get the middle one here, 1 plus 1. This is second coefficient. Last one remain the same here, right? So if I extend the power a plus b whole power 3 up to power 3, many students will know. So a power 3 plus 3a squared b plus 3ab squared plus b power 3. So here total terms are 4 are there. Total terms are 4 are there. And the respective coefficients are, first one is 1 and sum of these two 3. Again sum of these two 3 and last one is 1 here. Right. Up to this, many students will aware and known about this. So if I go for more powers, that means a plus b to the power 4 and a to the power 4, and the whole power is given to first term, that means 4c0 a to the power 4 and 4c1, selection of 1 power got reduced to a to the power 3, the power b starts here, b power 1, and 4c2, 6a squared b squared, and 4a b power 3, 4c3, a power 4 minus 3, 1 b power 3 and b power 4 here. Again the coefficients here, first one remain the same. Sum of these two, second coefficient, sum of these two, third coefficient, sum of these two, fourth coefficient, last one remain the same here. Like this I can extend up to any power. So these are the binomial, I mean this will come under binomial expansions. Now I would like to introduce the basic binomial expansion. So this is the basic one you have to understand. If you understand this expansion, everything is just a replica for this one, and based on this I can go for here. So a plus b whole to the power n, this we call as BE, binomial expansion. A plus b whole to the power n. So here a can be anything, b can be anything, but sum of two terms only. So power is n here, n also can be anything here. So a to the power n, that means nc naught. You can understand here, nc naught, out of n selecting none, nc naught. A is given the whole power, that is the first one here, nc naught a to the power n. Next one is nc1, second term here, nc1 a to the power n minus 1 b to the power 1. And the third term, if you want to write, nc2, so a to the power n minus 2, and b is given second power, nc2 a power n minus 2 b squared, and so forth. So this is the general term I am writing here, ncr k to the power n minus r into b plus next also ncr plus 1, you can write next term also. So on, the last one is ncn, that's out of n selecting n here, ncn a power nothing n minus n b to the power here. This is the last term here. So this is a basic expansion everyone has to understand here. So A may be anything, B may be anything, power may be any. Like generally we go for natural power here, right? So the important one is here, the key player is here general term. This is the key player in the binomial general term. So TR plus 1 is equal to TR plus 1 is equal. So NCR k power n minus R into B to the power R here. So by using, I can write any term in the expansion. Suppose to get the first term, R is equal to 0. And to get the second term, R is equal to 1. To get the third term, R is equal to. Like this, I can write any term in the given expansion. Another one is the number of terms in any binomial. Any binomial is nothing but power plus 1, n plus 1. Whatever the power is given, the number of terms will be based on the power. Number of terms will be n plus 1. So here I would like to give one example. Uh, the general term in the expansion x squared plus y whole to the power 10 whole to the power 10. So here k means x squared. If the plus is given, you can go with any order. There is no difference of that. Plus is given, you can go. But minus means you have to worry about the sign. So a means x squared, b means y, n is 10 here. So tr plus 1. The general term I am writing here. I don't know which term. So 10 cr, x squared whole power 10 minus r. Behind of this it is there. And y to the power r. So this is the expansion as well as how to write the general term and also number of terms in a binomial expansion done. Now, so the best one is a multinomial expansion, multinomial, like a multiplex, we can say in the towns. Like in binomial also we have multinomial theorem here. So beyond binomial. So by using this, I can go for any expansion. Any expansion may have 2 terms, it may have 3 terms, trinomial, it may have 4 terms by using simple notation here. So here the expansion looks like this: x1 plus x2 and so forth xk up to xk terms are there to the power n. So we know that many terms are there. I can't display, but by using sigma, I am writing summation n1 n2 sum nk. Each power is positive here. The sum of all powers will be equals to n. Beyond n, I can't go. At every stage, the sum should be. That means n is distributed over k objects, but whose sum is equals to n. So n factorial by n1 factorial, n2 factorial, nk factorial into x to the power, x1 to the power n1, x1 to the power n1, and x to the power x2 power n2, x to the power n2 here, x to the power n2 here, and x3 to the power n3 and so forth. So this is the simplest form of multinomial expansion here. So here binomial means you can elaborate and you can expand, but multinomial, by using the simple notation, I can write any expansion, right? So I am giving some important point here as a notes. The number of terms in any nomial, any nomial. So I'm writing here any nomial, number of terms in any nomial. So n plus r minus 1 c r minus 1, that I'm writing here, n plus r minus 1 c, n plus r minus 1 c, r minus 1 here. So n means the power of the expansion, r means the number of terms inside the expansion, number of variables you can say. So example here, x plus y plus z whole to the power 10, So power n is given. This 10 should be distributed over these 3 terms. So sigma 10 factorial by p factorial, q factorial, r factorial, x raised to p, y raised to q, and z raised to r here. But sum should be equals to 10. Here. So to find the number of terms, you can use this formula. Number of terms here. N is 10. Here n is 10. R is equal to 3. So therefore 10 plus 3 minus 1 c, 3 minus 1. That means I'm getting 12c2. 12c2 means 12 down 11 by 2 into 1. So number of terms will be 66. So my dear students, I'm trying to do the best for JEE and advanced. I try to give easy, simple, elegant. Please share and subscribe. Thank you so much.